Okay, here we are again, your favorite thing that we do in science, your geology quiz corrections. Hopefully this video will be a little bit shorter. Here we go. Question number 1, label the names of the layers of the earth and what they are made of. A lot of you guys missed that part. So this is your friendly reminder from Miss Cox to read the question carefully, okay? So if you read this question all the way, you would know that you needed to answer 2 parts of this. You needed to answer what the layer was called and what it was made of. So many of you remembered that this outer thin layer right here is called the crust, okay? This middle very thick layer, we call it the mantle. This layer right here is part of the core. We call it the outer core. And then right in the middle, we have the inner core. Okay, you guys know that. Now, when it comes to what the layers are made of, it's important to understand that the mantle and the crust are really made out of the same thing. Okay, they're both made out of rock, but the crust, because it's closer to space, is cooler. So the crust is made of solid rock. The rock is cold enough that it has cooled down. Whereas in the mantle, it's closer to the core where all of the heat is coming from. So in the mantle is made up of melted rock, also known as magma. Another really good vocabulary word that you can use for the word melted is the word molten. Molten rock is melted rock, okay? Don't forget that. Next, we have the core, okay? Again, the core, the inner core and the outer core are made up of the same thing too. It's just that the inner core is made of solid metal, okay? Metal are materials that are shiny, you know, like nickel, iron, okay? The core is made out of solid metal. The outer core is made up of liquid metal, and the reason for that is that there is so much pressure pushing in. Imagine all the mass of the weight of the whole earth is pressing in on this inner core. It's pressing so hard that the molecules in that inner core, even though they're very hot, they can't move apart from each other. They're stuck together due to all the pressure. So the solid inner core and then the liquid outer core, they are both made out of metal. Just like the mantle and the crust are both made out of rock. Question number 2, what is a fossil? Circle the best answer, okay? Well, the 2 answers that most of you guys thought were this one and this one. So let's have a look at the difference between them, okay? B says dead animals, dinosaurs, and people that are in the soil. Whereas D said rocks that have the print or shape of something that was once alive. So these are the 2 that were most similar, that were most difficult for you. First, let me show you a difference, what the difference is between soil and rocks. This is soil, okay? Soil is dirt, all right? It does actually come from rocks, but soil is the dirt that living plants can grow in. All right, now knowing what you know about fossils, you should realize that it's not possible for the remains of a living organism to be preserved in something like soil, right? It's too loose, it's too soft. Fossils are special because they last for millions and millions of years. They last for a really long time. And if you look at this soil, you would realize that no fossil is going to be preserved in that soil. A rock is a really hard substance. It is mud. Sometimes it's made from mud that has become hard over time. And the rocks can withstand millions and millions of years. Okay, so we know that fossils are formed when an organism like this insect here, this organism here, or even this fish here, Okay, a fossil is formed when these kinds of organisms get trapped in the mud, and then the mud turns into a rock, and then the rock keeps the shape or the print of something that was once alive, all right? And these fossils can give us lots of clues about the organisms that used to live in a specific environment. So the correct answer to question number 2 is fossils are D. They are rocks, okay, not soil, but rocks that have the print or shape of something that was once alive. Question number 4 is a question we have seen many times in class. And if you're still having trouble with this, or if you just missed some small parts of it on your quiz, please listen carefully to my explanation here. I am not going to give you a correct answer to this that you can just copy down on your quiz corrections sheet. I'm going to explain it to you. I'm going to give you the link to a really helpful video if you want to check that out, which I will also post on Edmodo, so you can just click on it. Okay, but I want you to try to come up with your own explanation for this without just copying one down from this video, all right? How do convection currents make the tectonic plates move? Use complete sentences to explain. Use the words mantle, core, convection currents, and crust. All right, one way that I love to think about this is I love to think of the tectonic plates in the Earth's crust like a person floating on the surface of the pool. And underneath them in the pool, imagine what would happen if there was a jet underneath them in the pool. If there was something that was making the water move in circles like this, imagine what would happen to the boy. If the water was moving this way, he would probably start to move that way too, right? If the water was moving the other way, like this, he would probably move in this direction. So I want you to listen to the explanation about what makes the mantle do this, move in circles, and then what happens to the crust that's resting on top of it. All right, in this image, we see the hot core of the Earth down here. And this area in the middle, this molten, melted rock, represents the mantle. So if this is the core, then this lower part of the mantle that's really close from the core, close to the core, is going to get really hot. And as it gets really hot, this part of the mantle is going to rise up to the surface of the Earth because hot things rise, okay? So this part of the mantle rises up. It's going to keep rising up until it gets to the surface of the Earth. And once it gets to the surface, this part of the mantle will cool and it will start to go back down. And the cycle continues in what we call convection currents. So the hot mantle rises up and the cold mantle goes down. And these convection currents are happening all throughout the mantle quite slowly on our massive planet Earth. Now, what happens over time as these convection currents continue, all right, the crusts and the tectonic plates, which are here in the crust of the Earth, if this is happening underneath them and these crusts are resting on top of the mantle, what's going to happen eventually, okay, is that these plates are going to move. They're going to move in whatever direction the convection currents are cycling. Just like if you were floating on top of a pool and the water underneath you was moving around like this, you would probably move in that direction too, all right? And so the direction that the plates move depends on the direction of the convection currents. If the convection currents were moving the other way, all right, if the convection currents were moving the other way, then the tectonic plates up here would travel in the direction that those convection currents are moving. Eventually, what will happen when the plates keep moving like this is that the surface of our Earth will shift. And this is why we have seen those tectonic plates move. And we've seen the continents get pulled apart, where they started off together and gradually over time, they move apart. Question number 3, quite a few of you did very well on question number 3, but you didn't quite answer the entire question. So Alfred Wegener hypothesized that the continents were once all together in one landform called Pangaea. and that they have moved apart over time. Okay? Choose 2 types of evidence that support Wagner's hypothesis and explain why these ideas support the idea that the continents are moving. Okay? So there are several different forms of evidence that you could have chosen to answer this question, all right? But the key was that you needed to make sure that you explained why these ideas are evidence of the continents moving. Whatever you write, you should make sure at the very end, to make it clear that you've answered the question, add something in like blah, 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 which proves that the continents are moving because blah, 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 blah. Okay? So some of the different forms of evidence that you could have talked about were the main types that we've been talking about in class and that we've talked about in our Plate Tectonics Detectives packet. So if you chose to talk about the shapes of the continents, you needed to tie it back to what the question was asking. So you could have said something like, Alfred Wegener noticed that the shapes of the continents look like they fit together in a puzzle piece, which proves that the continents are moving because they are no longer found together in one big landmass. They are found separate, so they must have moved apart. Okay, see how it's so important to tie back to the question? Okay, if you chose fossil evidence as one of your types of evidence, you should have said something like, well, fossils of the same organism are found on many different continents today. And those continents today all have different climates. So it's not possible that the organisms could be living on all those different continents today. They must have once all been together and had the same climate, which proves that the continents are moving because they have since moved apart and have different climates. So those organisms wouldn't be able to live there anymore. Okay? If you chose to talk about either earthquakes and volcanoes, you should have said something about how earthquakes and volcanoes form at plate boundaries. And we know this because the reason earthquakes form is when there's so much tension in the rocks due to the plate boundaries rubbing beside each other. Or volcanoes form at plate boundaries because either the crust is moving apart or it's moving together, which causes the magma or lava to come to the surface, okay? So you needed to connect it back, though. You needed to say earthquakes and volcanoes form at plate boundaries, which proves that the continents are moving because we wouldn't have earthquakes and volcanoes if the continents were staying still. It's only because they're moving that these even happen. All right, so the key was to bring it back to what the question was asking. And a lot of you guys are going to have to add something in to these answers to get full credit. All right, now here we are at the last question of the quiz, question number 5, which was your higher level question on this quiz. This was a question that you had never seen before, but we still expected you to be able to answer it using the concepts that we've learned. So, Hamid wants to build a house in a new place. Looking at the map, which of the places, A, B, or C, would be the safest for him to build his house? Explain why you think that place would be the safest, okay? So, now that we've talked about earthquakes and a little bit about volcanoes some more, this question makes more sense, all right? When you look at this map, we see a whole bunch of things. The blue lines, all right, we now know that the blue lines represent tectonic plate boundaries, okay? So we know that the Earth's crust is actually not a smooth surface, but it's divided into these different sections, which we call tectonic plates, all right? So the blue lines represent those pieces of Earth's crust that are separated into chunks, and the lines between them are the plate boundaries. And we have learned that those plate boundaries are pretty exciting places because those plate boundaries are where we find most of the Earth's volcanoes, all right? and earthquakes. So on this map, we see a red line, which is something that we call the ring of fire. The ring of fire is the area on Earth where we find most of the volcanoes. And as you can see on this map, it goes right around the Pacific Ocean. So remember, this is kind of a backwards map. Here we have North America and South America, and on this side, in between them and Asia and Australia, we have the ring of fire. Most of the volcanoes on Earth occur around that ring of fire, and we've learned that in our plate tectonics detectives packet, all right? We've also learned that at plate boundaries, like these, all these lines, this is where we find lots of volcanoes, but also where we find lots of earthquakes, okay? So when you read this question, what you needed to realize was that any house that's built near a plate boundary, so on any of these lines, would be a dangerous place to live because there would be earthquakes and volcanoes happening there. So that's what I was looking to hear in your answer. I was looking to hear you refer to the plate boundaries, and I wanted to hear you say that location A and B would not be very safe because they are close to plate boundaries, and at plate boundaries we find lots of earthquakes and volcanoes. All right, the correct answer here was that C. Location C would be the safest because location C is right in the middle of one of the tectonic plates, and it is far away from any plate boundaries. Okay, don't get confused here. All right, a few of you said, you were almost right, a few of you said that location C is the safest because it's the farthest away from any tectonic plates. Well, that's not quite true because you can never be anywhere on Earth that's away from the tectonic plates. Look, they cover the whole Earth. And what you meant to say was that location C is the farthest away from any plate boundary. All right? So that's what I'm looking for in your answer for number 5.